So as you can see, the handouts that you have are identical to the sheets that I'm going to be doing up on the smartboard, okay? So we just work through them as a group, and away we go. Sometimes I have an extra bit, just so I can keep track. Does anyone want a graphing calculator before we start? Does everyone have a calculator of some sort? See most people. If there aren't batteries in them, just let me know, and I'll put new batteries in at break. Okay, so a little bit of review getting ready for this unit. Depending on when you took your last math class, some of this you might start it again and be like, oh, what? I have no idea. I haven't done this in forever. It is not a big deal. Trust me that I will get you to where you need to be, okay? We just got to warm up a little. So first things first, we're going to start with some algebra, and we're going to solve for an unknown variable, okay? So in this case, my first one, I have 4x equals 12. When there is a number next to a variable, that means multiplication. So when I'm solving for a variable, I do the opposite of what that operation was. So currently that means 4 times x. If I want to get rid of the 4, I'm going to do the opposite. So the opposite of multiplication is division. So I'm going to divide by 4. If I do it to one side, I have to do it to the other side. 4 divided by 4 becomes 1, and I don't need to show a 1, so I just leave it as an x. And then 12 divided by 4 gives me 3. So the answer to my question is x equals 3. Okay? Also, when you are solving for an unknown variable, does everyone remember BEDMAS? So how you would solve like brackets, exponents, division, multiplication, addition, and subtraction? When you're solving, it's reverse BEDMAS, okay? So you get rid of your addition and subtraction first. Then you work with your multiplication and division, all right? The only mess up here is if there is a bracket or an exponent, you do need to clean that up first, okay? But that'll be very obvious to you because you won't be able to move anything until that bracket's gone. Sound good? Okay. So again, if I'm looking at this, I have 4x minus 12 equals 8. Does anyone remember in the past how their teachers did this? What I like to do is, who has played Red Rover before? Everyone at least knows the premise of Red Rover, right? 2 sides, you run across. If you can't break it, you end up being on that side, okay? So what I say is, you're going to play Red Rover. So you're going to circle the entire number, including its sign, as a negative. Now, because I want to get it away from the x, it's going to run over here. As soon as it runs to the opposite side, what happens to its sign? It changes. Awesome. So I get 4x equals 8 plus 12. Now, you don't need to show that 8 plus 12 if you don't want. You can do that addition right away. It's whatever you're comfortable with. The more steps you show me in the question, the more part marks I can give you if you gave me the wrong answer. Okay? If you only write x equals something and you don't show me how you do it at all, and you just got even a number backwards, I have to give you 0. If you showed me how the numbers are coming through, then I can give you part marks. Okay? So I have 4x equals 20. Now I'm on to the same question as the first one. I have a multiplication. In order to get rid of that multiplication, I divide. So I get x equals 5. Now, when moving an addition or subtraction, there's tons of ways to do it, okay? Some people put an addition underneath on both sides, or just move it over. Whatever you're comfortable with, you do it. Okay? If you don't like the way I did it here, and when you go to do your homework, right, once we're done this lesson, you want to try something else, just say, Helen, can I do it this way? And I'll say, absolutely. Okay? It's not a big deal. All right. Next one. So I have 2x squared equals 50. So first things first is I want to get rid of that 2, so I'm going to divide both sides by 2. I now get x squared is equal to 25. X squared, the opposite of a square is a square root. Okay? The opposite of a square is a square root. So in order to get rid of this, I'm going to take the square root of x squared, and then I have to take the square root of 25. Okay? Those square roots the square root cancels out the square, okay? Because they are the opposite math operation. They're the opposite math operation. So if that was a cube, you'd want to take the cubed root, okay? It's going to be the opposite math operation. Hey, how's it going? And the square root of 25 is 5. All right? Okay, so we're trying D, E, and F. Let's give you a second and then I'll start looking at them. Remember, move any addition and subtraction first, and then deal with any roots, exponents, etc. Unless anything was in a bracket. Okay, so in this first question, what's the first thing I'm going to move? The 7. Are you guys comfortable with me doing it this way? Moving it over, so I get x squared equals 74 plus 7. So x squared equals 74 plus 7 is 81. Thank you. In order to get to the get rid of the exponent of 2, I take the square root. Absolutely. If I do it to one side, I must do it to the other side. Think of it as a balance or a scale. So x equals 9. Again, you show the steps you want to show, but the more little steps you show me, if you make a mistake, like let's say you just rolled 6 instead of 9, okay? You would only lose 0.5 on this question for getting the answer wrong, and you'd get the rest of the marks for showing me some work, okay?
So it only be x. Would it be x squared?
No, because the x squared has been canceled by the square root sign. Okay? We want to get x by itself, right? We are isolating x. We are getting it out by itself. Yeah, that's it. Yeah, that's fine. That's fine. Yeah, yeah. Okay, next one again. Just is a fluke that it's a -7 again. So I get x cubed equals 20 plus 7. So I get x cubed equals 27. I said this verbally to you guys before. Exponent 2 is eliminated by the square root. Okay? Exponent 3, exponent 4, exponent 5. It doesn't matter what exponent. You can do multiple roots. Does everyone agree with that? So in order to get rid of a cubed root, an exponent of 3, I take a cubed root. So what I do is I just put a little 3 in the crook of the root sign. Okay? This is called a cubed root. I can take a 4th root, a 5th root, a 6th root. I can take any number root. Okay? So no matter what the exponent is, I put a root sign, and I put whatever that number is in the crook of the root sign. Okay? And then here I have to take the cubed root of 27. Again, the cubed cancels out the cubed root, so I'm left with x. Now, cubed root of 27, if you have a graphing calculator, you need to hit the math button, which is the 3rd button down, on the left-hand side, and you will see the cubed root. If you have a scientific calculator, there is probably a button somewhere that says cubed root. Okay? So I'm going to hit the cubed root. So I hit number 4. Cubed root of 27 gives me 3. Everyone make sure they can get that on their calculator at some time between now and when you're going to start your homework. So if you get stuck, I can come over and help you with the calculator part. Alright? Sound good? Okay, sweet. Okay. Pardon? The batteries aren't working? Just leave it here and I'll grab some more batteries. Hopefully that one's okay. Okay, next. So this one, they're just trying to throw you off. Because what is pi? 3.1, yeah, there's tons of decimals, but for this class, you can just use 3.14, okay? So first things first, I'm going to put this in a different color just because they get close. I'm going to go 96 equals 3 times 3.14x. Okay, I'm going to clean up that one side right away. If you want to use the pi button on the calculator, that's absolutely fair too. I will always check your answers. It'll just give us a different decimal. But I got 96 equals 9.42x. Who agrees with that? Now, in order to get rid of that 9.42, I'm going to divide both sides by it. These cancel to 1, right? So I get 96, bless you. 96 divided by 9.42 gives me 10.19. Does everyone agree? Yeah, I'm only closing my calculator. You have all done this before at one point or another, so it's hopefully coming back to you, or you never lost it, or whichever.
Just like I totally forgot it.
Yes. Yes. Okay. The women's washroom, like the girls' washroom, go down the main hall. You'll hit the entrance to the building. Just a little past that, it's on the right-hand side. Okay. What do you think? Does everyone have this written down? Okay. Did you? Did everyone else get what I got? Or did I type it in wrong? 96 divided by 9.42. I got 10.19.
Never mind, I wrote it.
Same answer, but I didn't do it that way.
You didn't. That's fine. You could have done it all in one division. You could have done it multiple different ways. I'll look at it in a sec, okay?
Well, I erased it because I thought it was wrong.
Oh, no. Don't ever erase it because when it's multiplication, it doesn't matter the order in which you do it, right? So the way you do it just might be different from the way I do it.
Okay.
I tend to hopefully break it down just in the most basic way so everyone gets it, but if you see it a different way, just leave it, okay? Alright, I forgot to print something for you, so just give me a second. Okay, so make sure you have the formula sheet, which I just handed out. So convert each of the following questions into units that it asks for. So hint, use the decimal jumper for AB, and use the conversion chart for CF. I just gave you a formula sheet there. Okay, so if we're looking here at the front side, this is Bentley's conversion sheet, he made it. So a handy decimal jumper chart. I don't think I used to have it up on the wall, but I don't think I do anymore. Okay, so underneath it, it actually tells you what this is. So let's say you want to convert 0.7 kilometers to meters. You would just put your finger on the kilometers above and then jump over to meters. How many jumps is it? 3 to the right. Do the same thing with the decimal and you will end up with 700 meters. Okay, the decimal is always there, but sometimes invisible. Even in your age, if you are 18 years old, the decimal is always right beside the 8. Okay, so, for example, if we're going 10 kilometers to meters, you come to this chart and you put your finger on kilometers. How many jumps is it? 1, 2, 3. Does everyone agree with that? So what he's saying is there's always a decimal here, even if you don't see it right after the number. So you're going to jump it 3 times. So 1, 2, 3. So that means you add 3 zeros. So 10 kilometers